Hi folks, welcome back to 6.2 Disc and Washer Method Practice. In this video, we're going to take a look at question number 7. Question 7 says, find the volume of the solid of revolution generated by rotating the area between the graph of f of x equals x squared and g of x equals 1 over the interval from 1 to 4, and we're revolving this around the x-axis. So let's get started with our graph. Our graph of square root of x should be pretty quick for us by now. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. And I'm going to go ahead and connect all of these with my curve, and that's my f of x. All right, let's draw our g of x. G of x equals 1 is just the same thing as the horizontal line, y equals 1. All right, what's our interval? We're starting at 1 and we're finishing at 4. So we're looking at the region inside the pink, purple, and orange. And finally, we are rotating this around the x-axis. So area or axis of revolution is y equals 0. All right, so let's go ahead and draw our reflected situation. So I've got a space down here, and I know that it's got that, and it finishes at 4. Okay, so I can see here that this is going to be a case for a washer method. And that is the time when I have pi outer radius squared minus inner radius squared. Okay, because this is the kind of shape that looks like a donut. So I'm going to have a circle, and then inside that circle I have another circle. Okay, so I have a hole in the middle of this function. Now, if I draw it using the colors that I have on the graph, the outer function is going to be the pink curve, and the inner function, the one closer to the axis of revolution, is going to be the purple curve. Okay, so maybe this picture is a better picture for us to see the inner radius and the outer radius. So inner radius is going to be the little one. Oops, sorry. Don't know what happened there. Got my inner radius, my inner circle. But the inner radius is the little one, and the outer radius is going to be big R. Okay, now where is this radius coming from? This is when we talked about the area between two curves. And so we need to think about top minus bottom, meaning here's a radius, here's another radius, here's another radius, here's another radius, and those are all pink minus purple. So we're going to use that in our washer setup in the integral. All right, so our integral setup, volume equals the integral of area. And I'm going to go dx because all of my blue lines are perpendicular to my axis of revolution. So from A to B. All right, I've got the integral from 1 to 4 of pi times the big radius is the square root of x squared minus 1 squared dx. And I'm going to simplify this. Pi, the integral from 1 to 4 of x minus 1 dx. All right, let's integrate. This equals pi 1/2 x squared minus x, plugging in 4, plugging in 1. So 1/2 times 4 squared minus 4 minus 1/2 times 1 squared minus 1. All right, so we've got 16 over 2 minus 4 minus 1/2 minus 1, which gives me pi times 15 over 1, because 16 halves minus 1/2 is going to give us 15 over 2, and then negative 4 plus 1 is going to give us minus 3. This is going to go to 15 halves minus 6 halves, and then we can get our final answer of 9/2 pi. Okay, so let me zoom out so you can see the whole question. But again, this is a case of washer method because I have this whole region on the inside. Okay, that region right there that gets scooped out, and I just have the region around it, and that's how I get the washer. All right, folks, we're going to stop here for question number 7. Come on back for question 8.